resistance. All right. So the testing of isolating transformers, according to the in-service safety inspection and testing of electrical equipment, ASNZS 3760, and the current model we have is 2003. The requirement to test isolating transformers should be checked first as to the monthly, annually, 6-monthly checking, depending on the environment in which it's in, which is table C, I think. Appendix C is good because it gives us the written word of how to do the tests, insulation resistance tests, and the next best thing, if you can't read very well, is pictures of how to do the tests. There's the next 2 pages over, next page over. Alright, so an isolating transformer is like most things in the electrical engineering industry, electrical supply from another. There are 2 sets of windings inside. Primary side, secondary side. The primary side has a phase and a neutral test that we have to do. The neutral is hooked up to the earth back at the distribution board, but when you're testing the appliance, no earth connected. The secondary side doesn't have a phase and a neutral. It has a line 1 and a line 2. They're not called phase and neutral anymore because the phase isn't connected to the phase, the neutral isn't connected to the neutral or to the earth. The whole idea is one side is not electrically connected to the other. They're connected by electromagnetism. AC theory will tell you there's an expanding and contracting magnetic field. The magnetism joins one side to the other. That's almost a completely new subject. So the idea is, my expectation would be visual test first. Visual test, is the appliance in good working order? Is the plug top okay? Is it suitable for use in New Zealand? Is it secure? Is the lead damaged in any way? Apart from glue from the last sticker across the lead. Someone's wired it through there, which would probably be a reason for a fail, which we will fail on. Is it secure in there? Is it going to fall out of there? No. Are all the nuts and bolts secure in place? No, they're not, because we're going to be looking inside it. Is it damaged in any way? Has it gone rusty in any place? No. Does the label say that it's suitable for use in New Zealand? Yep. Okay. Should I do an earth continuity test on it? And on what grounds? Earth continuity test on class 1 appliances only. This one here, this particular, yep, down there on the nameplate, class 2. No earth continuity test. You kind of have an expectation that the earth pin would be kept to the outside case. It's not. Okay, we should check that. It is it's a metal case on the outside of that. We're going to be checking that. So there's no earth continuity check to be done. Is this side of the appliance connected to this side of the appliance? That side of the appliance? No. Okay. There's electrical isolation. That's an insulation test. What continuity checks could we do? What should be continuous? Have a look at the drawing. There should be continuous through there and out the other side. There's a meter. Quick check first. Does our meter work? 014. One probe on there. One probe on there. Continuity check, part 1. 1.63 minus a few. Primary side, secondary side, this side of it, secondary side through there. I'm expecting it to be very similar. Two, slightly higher, but certainly the phase of line 1 and line 2 of that side of there are joined together. Insulation resistance tests. From there to exposed metal on the case. Now we've removed the screws so we can look inside it later, but it also gives us a chance for now to get into some bare metal. Hold that on there for me. Push that button. Oh, does the meter work? Push the button. Meter works. Push the button. open circuit. We'll try this one anyway, just in case someone's made a mistake and hooked the end of the lead up. No, and that's all you have to do on that side. On the secondary side, same deal again. On there, we know it already goes all the way through. Onto some exposed metal, push the button. Open circuit. Again. Okay, this is proving the thing there is insulation between the two sides. And now, the earth on this side to the earth on this side, they should definitely not be connected together. Push the button. Open circuit. The phase should definitely not be connected together. It's open circuit. So there's no electrical connection between one side and the other. Rewirable fuse on this side, thermal fuse on that side. This one here will protect against short circuit. That one there will protect against overloading, plugging too much stuff in. If you've got a drawing to refer to, if you have a look at the drawing here, the test we did was through there for continuity, through there for continuity. We checked to make sure that that side was not connected to earth. This part here is disconnected from there. That connection there is at the fuse board. We checked to make sure we had continuity through there. We checked to make sure there was no continuity between there and the earth plug, that side there and that side there. If you get stuck on doing these, make a drawing up. Good? Easy. Get on with it. The stepper motor as a generator.